All righty. So today we're going to talk about TypeScript. So first question is, what is TypeScript? TypeScript is Microsoft's dream come true. A while ago, Microsoft apparently tried to create their own web language to replace JavaScript, and it thankfully failed miserably, probably because no one supported it except for IE, which is a browser no one should ever use ever anyway. TypeScript is the 2.0 iteration of that, but it's actually an implementation that people can use because it compiles down to JavaScript, and JavaScript is actually supported absolutely everywhere, on everything that has a browser. And we'll talk about that a little bit more in a bit. So first thing we need to look at is JavaScript, because TypeScript is a superset of JavaScript and compiles down to JavaScript. So this is vanilla JavaScript, right? And so we got this function called sum. It takes in num1, num2. Diff takes in num1, num2. Divide takes in num1, num2. And then full name takes an object, which has a first name attribute and a last name attribute. And we could tell all of this because we actually had to go through the entire function and see exactly what it was doing. And back in the day, this is what JavaScript was. If you wanted to use the function full name, you had to pull up the function full name and see what the heck it was going to do, and that would tell you what you actually had to pass into here. There's a lot of different methods that came about trying to get around that. A lot of times you saw this pattern where people would be like, person, has a first name key and a last name key. And they would do it that way. But then again, you'd have to open the file that the other function was in so that you could even read those docs. And then again, you had to read what was going on in the function to even understand what it was going to be doing. So TypeScript is among other things a way to protect yourself against that kind of stuff for free. So before we go to the TypeScript file, let's take a look at this. Right? This is calling all of these things like with happy paths, right? 1 and 2, 1 and 2, 1 and 2, and the sum, diff, and divide things. And then the full name thing is passing in an object with a first name and a last name. Everything will be happy, right? If I try and run this, node javascript.js. Wait, is it in the source folder? Yes, it is. javascript.js. So I run that, and look at that. It's happy. Everything's great. 2 plus 1 is 3, 2 minus 1, 1 minus 2 is -1, and then you divide them, you got 0.5, and then full name spits out my full name. But let's see what happens, and this is vanilla JavaScript again. If we do this, you can see here, I'm going to pass in an x and a y into this function when we're expecting numbers, right? Same thing with here, same thing with here, same thing with here. So this is going to give us nonsensical crap because JavaScript doesn't care about types. X, Y, nan, undefined, undefined, right? And if this is running in a browser, which is where JavaScript usually runs, it's going to be spitting this kind of crap out to the user. Honestly, it might be a worst case scenario if you have like a node server running JavaScript and it's saving data this way. That probably would be worse. So that is JavaScript, and those are the pitfalls that came with JavaScript. So this is TypeScript. First thing you'll notice is that there's a lot of red squigglies here. The reason for that is because TypeScript, by default, will not allow you to implicitly set something as an any type. Any in TypeScript this can be literally anything. It's just base JavaScript. And obviously, it kind of undoes the entire purpose of TypeScript. And so it's good to not have implicit any's. And it's not good to turn this rule off, because you can't turn that rule off because you don't want this stuff. So let's see what it looks like, what this file looks like in TypeScript. I'm telling TypeScript that these two things are going to be numbers. And I'm going to, do this, number. So now TypeScript knows all these are going to be numbers. And if you hover over one of these functions, you can see it's going to take in a num1, which is a number, a num2, which is a number, and it's going to return a number. because TypeScript is very, very good at inferring types. And so those three are all going to look that way. But let's get here to this person. Person is an object. So how do you type an object in TypeScript? Very, very simple. Export interface. You use an interface. I'm going to call it person. Generally, you see them Pascal cased, which is, all cap. Every first letter is capital, including the first letter of the first. Excuse me. And so a person has, as we already figured out, a first name, which is a string, and a last name, which is also a string. And so now we can type this with person. And so now TypeScript is happy, and TypeScript knows that person is going to look like the person interface. It's going to be an object that looks like this. This, interfaces specifically, is huge, considering that objects in JavaScript could potentially have hundreds of key pair values, and then even nested objects, and all of the guesswork is completely removed with TypeScript, which is wonderful and magical. Speaking of nested objects, what if I had a birthday of type birthday? Well, it's very easy to also type the child object here by just using another interface. Use the interface birthday, right? Birthday probably has a month, which is a string, day, which is a number, and then year, which is also a number. Oh, thank you, TypeScript. It just did that automatically. Look at that. So now if this is another wonderful fun thing about TypeScript. If I do this, if I say I'm going to create a variable named birthday, it's going to be of type birthday, and that's it. Well, now you can see birthday is red squigglied, and if you hover over it, TypeScript says, hey, this is missing the following properties from type birthday. You need a month, you need a day, you need a year. This comes majorly in handy if you are ever creating birthday in one file and the interface birthday is in another file, right? And so like if you, let's say you couldn't see this here, lines 7 to 10 there, then you could just hover over this and it'll tell you right in this file exactly what you need for this object. So I'm gonna do month, December, and then day is gonna be the 24th, Christmas Eve birthday. And then the year is 1980. Oh, look, I just totally made a mistake. I did that as a string, and TypeScript immediately said, hey, year is a number, not a string. That could have ended with some crazy JavaScript stuff, but I caught it immediately because TypeScript immediately underlined it, and TypeScript is magic. So there we go. Now, having month be a string probably isn't entirely helpful, right? That's not too type safe, right? Because it means month can be literally any string. So if I did this, bro is not a valid month, but TypeScript is happy with it. There's no red squigglies. So there's several ways that we can tackle this. You can use an enum, which looks like this. And then the implementation of this is going to be, I'll show you in a second, but like these are a little wordy, right? You see January equals January, February equals February. It's a little wordy. It's a little cumbersome to use enums. And then in the browser, when they actually run in the browser, they get turned into numbers sometimes, but not others. So it's a little confusing. So I've seen enums fall out of popularity recently and replaced with something else. But if we do use the enum thing here, so we tell birthday that month is going to be of type month. That's importing it from the enum file there. And so now you can see, you're not allowed to set month to bro because that's not a month. And so you can do this and do month dot whatever, December, right? And so now it's happy. The other way you can solve this, and this is the one that I've seen more often recently, is to use a union. The union parameter. So here you can see month union is a type, and it's going to be either January, February, March, April, May, June, July, August, September, October, November, December. So in here, we can change this to month union, import that from the union file. And then here, you can see it's mad. Doesn't know what month is anymore. And so now if you start typing, Look at that. You just type the string thing, and it's like, hey, I know these are your 12 options. Which one do you want? You just boom, January. And there you go. Now, the other cool thing about using that union operator thing there to type the month union type is if I accidentally type 2 Y's or an H and a Y even, look at that. It's mad. And I immediately, before even running the code, I'm able to see, hey, January he is not a real month. Oh, yeah, that's right. I accidentally typed an H and a Y at the end of that. Let's get rid of that. So you can already see that TypeScript is offering you free unit tests for your code base. If you're using TypeScript in your code base, your code will not compile until all of your TypeScript errors are taken care of, which means that you'll never be able to accidentally pass or set the wrong type somewhere. You'll never be able to accidentally, if you're using this month union thing, have an incorrect month sent somewhere, and it is wonderful. Now, here is the caveat about TypeScript. It's the one little caveat. TypeScript itself does not run, right? It compiles down to JS. So if I do this, console.log birthday, there's no way for me to see what this is going to spit out until I compile this code down to JavaScript code and then run the JavaScript code. This is mostly a good thing, and we'll get to why in a second, but it does mean that these types only help you before your code actually runs. So if I run the TSC compiler with TSC here, and TSC comes when you install the TypeScript npm package. Oh, I left that stuff in from the previous. Where is this? OK, let's get rid of this. Sorry, this is from yesterday's. Oops. Yesterday's iteration of this. OK, now it should be happy. So if I run TSC, it compiles my code. And if I do an ls, you can see there's now a dist directory here now that wasn't there before. So if I open that up and I look for TypeScript.js, boom, this is my compiled code. You can see it's kind of hard to read because they're not going for readability here. They're going for functionality. But this is the code that I just wrote in JavaScript, right? You can see all the type stuff is gone. And so if I run that, right, I do a node, not JavaScript, dist TypeScript.js. I run it. Look at that. There's my birthday console.logged. That's wonderful. So right. So here's the big caveat. What if I still have this here, right? TypeScript's not happy, right? It's mad because January he is not a valid instance of the month union type. But if I run TSC, take a look here, TSC does explode. It says, hey, this is not allowed, right? But if I run that new code, TypeScript.js, you can see January he is still there because JavaScript doesn't care about types, right? So this is one of the very big differences between TypeScript and any other strongly typed language. TypeScript will compile your code if there's an error. Any other language will not compile your code if there's an error. Any other strongly typed language. But as you can see, TypeScript is totally fine with just spitting out that JS code. It definitely warns you about it, but it definitely spits out the compiled JS code, which will then have the errors in it. So yes, if you ignore your TypeScript compiler warnings or errors, your code will still happily run with incorrect types because JavaScript. But the easy solution to this is, don't ignore your compiler errors. You can set your CI servers to fail a build if a TypeScript error comes up. So there's no chance that this is going to get to production, right? This faulty code should not ever be able to get to production. If it does, someone did something wrong. But I say all this to say that there will absolutely be times that you will miss a compiler error and your code will start behaving really weirdly and you won't understand why until you finally see the compiler error, 10 minutes, 20 minutes down the road, maybe even an hour or two down the road. And then you're like, oh crap, that's why everything's been weird. This sounds dangerous, but again, You can use your CI build to stop code from going anywhere if the compiler fails. So that's the one caveat with TypeScript. But again, the fact that TypeScript compiles down to JavaScript with that one caveat aside is a very, very good thing, because literally every device with a browser runs JavaScript. And TypeScript does the work to compile your code down to whatever version of JavaScript you need for free. So let's take a look at tsconfig here. This parameter here, target, tells TypeScript what version of JavaScript you are targeting. And if we scroll over here, you can see it goes back all the way to ES3, which is kind of ridiculous because ES3 came out in 1999. Any browser that does not support something newer than ES3 is very deprecated and no longer maintained at this point. And here's the best part about TypeScript. TypeScript has now surpassed JavaScript in its capabilities, and you can use all of that new flashy functionality even in browsers from 1999. You want to use async await in IE5? I don't know why you would want to, but if you do, you can do that with TypeScript, because the TypeScript team has done all of the work necessary to figure out how to turn async await into functioning ES3 under the covers. And you get all of that for free. It's wonderful, it's magic, and TypeScript is amazing. But it gets even better. The flexibility of their typing system is incredible. I used to hate strongly typed languages. In fact, I still hate strongly typed languages. I love the flexibility that you have with untyped languages. And that tends to always be the debate, right? Those who prefer untyped languages just want to write their code without having to fight with some typing system that's forcing them to spend all of their time trying to figure out how to type something. And then those who prefer strongly typed languages, like that you can't accidentally shoot yourself in the foot by thinking like a human instead of a computer, which we all tend to do every now and again. TypeScript is the perfect merger of both of these things. It is the best of both worlds. So if we take a look at untyped goodness, oh, this is the dist folder. We don't want that one. Untyped goodness.ts. Let's take a look at this function here. This function, get name and ID, takes a thing as a parameter, right? And I don't care what kind of object thing is. All I care is that it has an ID and it has a display name. So let's say I have two different types here. Interface car with display name, which is a string, ID, which is a string, year, which is a number, make, which is a string, model, which is a string. And then I have another interface phone, which has display name, which is a string, ID, which is a string, and manufacturer, which is a string. This is one of my favorite things, if not my favorite thing about TypeScript. It makes it stupid simple to be able to use either of these things in this function using the union operator that we looked at earlier. So we have car or phone. So now TypeScript knows that the thing being passed into here is going to be either a car or a phone. They both have an ID and a display name, so TypeScript is totally fine with doing this. Doing this in other strongly typed languages is a massive pain and wastes a ton of time trying to set it up just to get the language to be happy with it. And so, it takes so much time to do this that you end up having the same exact function in two places because it's way easier and quicker, and that infuriates me. So what is this union operator actually doing? Let's take a look. You can see, again, TypeScript is happy with thing.id and thing.displayName, right? But what happens if I want to access a field that exists on car but not on phone, right? Let's add another dash, do this, and say thing.year. That is not cool. TypeScript is not happy with that because year only exists on car and not phone. This can be a little bit confusing because the union operator is the pipe, which everywhere else means or, right? And so you see it and you immediately think or, but it's not an or operator. It is a union operator. And what the union operator does is allow you to access fields that exist on both a car and a phone. They both have ID, They both have display names, so those two things are happy, but only one of them has year, and so you can't access year in this function. And this kind of makes sense if you think about it. This function is going to run on either a car or a phone, right? So if I try to access phone.year, JavaScript will explode because a phone, if something's coming in as a phone, it doesn't have a .year, right? And the whole point of this function is you want to use it for both a car and a phone. And so you can't access a key that is only on one interface and not the other. So that was kind of a small tangent to show off the flexibility of TypeScript and to show off the union operator, because it is pretty important and it comes up a lot. So we're going to talk about another important TypeScript feature, which is generics. Generics.ts. I'll do this again. All right, so here is a function. This function doesn't make sense because all it does is take in a thing and then immediately return that thing. But so it's not like it doesn't have any actual functionality, but it's very good for explaining generics. So bear with me for a bit. So we have a thing, right? TypeScript is taking the thing in and it's passing the thing back out. So this function is going to return whatever type is passed into it, right? So if this is a number, it's going to return a number. You can hover over that. TypeScript immediately knows. If it's a string, it's going to return a string. But how do we tell TypeScript that this function is going to return whatever is actually passed in without picking one type for this function? We could manually create 800 different versions of this function, right? We're like generics example string. Okay, that's a string. And then we want one for number, so we have to name it differently because it can't have the same name as the other thing. And then now it's a number. If you hover over that, you can see, that's not dry, right? That is very, very much repeating yourself. And so we could use generics. Generics can be a little difficult to wrap your mind around. So, if you have any questions, please ask. But this is the syntax. So now you are telling TypeScript that when you see angle brackets, anytime you see angle brackets in TypeScript, it is it's using generic types. So here we're telling TypeScript, this function is going to take a thing of type T. We don't know what type T is until someone actually uses this function and passes something in, and then we'll know what type it is based on what they're actually passing in, right? So it's going to take a thing of type T. That thing is going to be type T, and it's going to return a thing of type T. So the angle brackets T is delineating a random type that is going to be referred to as T for the purposes of this function, and it is, a generic type. So let's actually implement something that uses this, right? So if I do generics example number, I'm going to pass in a number, right? If I pass in 3, we hover over this, we see TypeScript automatically knows, okay, you're passing in a number, so that's going to be the thing that is returned. It's also going to be a number. But if I change this to string, well, one, if I change it to string and don't change this, TypeScript's like, hey, that's not a string. So now if I wrap that in quotes, we hover over this, we see it takes a string, it passes back a string. So generics are super powerful for stuff like this. And the place where you're going to run into generics all of the time is promises, because promises, are pretty common. So if I hover over this, you can see async function is a promise, but promises return a type, right? When they finally resolve, they will return something, and you have to know what that something is, right? And so in this case, it's a number. If you hover over here, in this case, it's a string. And so you'll see generics a lot of times when you're working with promises. That is the most common use case for generics, I think. And then you can also do some really, really cool things with generics. For instance, I will show off fixture. It's fixtures / fixture. So on HCV, and prior to this, IQVIA is where the idea originally came from. I think Robbie Duvall was the one who came up with it. But this is a function that will take some defaults for a fixture and then override it with anything that is passed in to override it. So to do that, you need a default of a certain type, right? You need overrides that's going to be a partial of that certain type. We'll get to partials in a second. And then you're going to put a thing, and you're going to take this object, you're going to put defaults into the object, and then you're going to override the defaults with the overrides, right? The generic type here makes this super simple and awesome to implement, to use this function with whatever fixture you're working with. So if I come up here and I go to accommodation category, you can see at the end here, we're calling make fixture, right? If I hover over make fixture, it's saying, oh, look, we're going to call it with an accommodation category. And so it's going to return an accommodation category. So you create your defaults here. You pass that into here with the overrides that the user passed in. And then it returns a type of accommodation category. And this tells TypeScript we're working with accommodation category for this implementation of the make fixture function. So it lets you do some really, really awesome and powerful things if you use generics. Oh, sorry, I thought you were asking something. That is generics. Now let's talk partials. If you see partial in TypeScript, it means that the thing that you are typing will only be a, wait for it, partial of the interface it's using. So that means that plain here is only going to have some, maybe even none, or potentially all of the keys that are in the plain interface. So if I do this, const type equals plain.type.name, you can see TypeScript is mad here because it's a partial, and so type might not be there. And so if I try to access name on type, JavaScript is going to explode with you can't access property name of undefined, right? And TypeScript will always yell at you like this if something is potentially undefined and you're trying to grab some kind of thing on undefined. So speaking of which, if I do this, plain, but then I do this, it's still mad. This is a full implementation of plain, but question mark here in the interface means type is optional. It might not be there. And so when you try to access name off of type, TypeScript says, hey, you can't do that. You have to check to see if it's undefined first. And so you'll see stuff like this a lot. You just have to do an if statement to see if it exists, right? Does plain.type exist? No, plain.type, question mark. That's the ternary thing. Then you can do plain.type.name. Otherwise, you're returning undefined. Very recently, TypeScript has come out with some functionality that shortens this syntax, right? So instead of doing a ternary like this, you can do this. And all that question mark is telling TypeScript is, hey, type could potentially be undefined. If it is, just return undefined for this, and then type will be undefined. And if I hover over type, you can see it's going to be either a string if name exists, right? Because name's a string, or it's going to be undefined because if this doesn't exist, it'll return undefined. So that is TypeScript in a very small nutshell. There is one more thing. If you want something to be an array, right? If this is going to be an array of type number, then you do number and you just do array brackets, right? So now number of engines is going to be an array of numbers. And now if I do this, do plain type array, you can now see TypeScript's mad down here because name does not exist on type array, right? Because this is now an array. So now you'd have to do something like this. And then, wait. What?
Before the question mark?
I think maybe the question mark should come after. No? Oh my goodness. Okay, I don't know why it's mad. Name does not exist on type number array. Oh, I think that might be Visual Studio like freezing up and still thinking this is a number. Wait, no, because I don't know where it's getting number array because type is a plain type of type. Maybe this syntax doesn't work with the array at the end of it. Let's change this back into a ternary. Plain.type at 0. It's a name. There you go. And then I guess undefined would be the other thing. So yeah, I guess that the question mark does not work with if you're trying to access a value of an array afterward.
if you do the if statement check instead of the ternary thing, you would just check if it's equal to undefined. Is that how it works?
Yeah, you can do that. That's one thing you can do. So you can do like plain.type does not equal undefined, right? That's going to accomplish the same thing. The ternary is just a little, a little more concise, and then you can just do, have all your extra logic in here or whatever, whatever you want to do with plain type. You can also do, this is JavaScript shorthand for if plain.type does not equal, or sorry, if plain.type comes out to truthy, then go ahead and do whatever's in here.
Do null types exist in TypeScript?
Yeah.
What's the difference between that and undefined?
So null, I can show that very quickly here. This is a JavaScript thing. So undefined, if I try and access x is not defined. That is undefined because it's never been instantiated, right? If I do const x, right? So I've declared x. Oh wait, right, because that's a const. So I've declared x, but now if I hit x, oh shoot. Okay, I thought that was going to be null. X can be null, and then it's just an empty value. But if it's undefined, it means it was never defined to begin with.
So there's no type associated with undefined?
Just in TypeScript, the type is undefined. So I can do, instead of doing this question mark thing, I can do this.
Okay.
And it's essentially doing the same thing.
Okay, I see.
And so like I hover over that plain type array or undefined, but if I do this, and I hover over that, it's going to say the same thing.
Okay, got it.
Any other questions?
I'm good.
For generics, do you always have to use the letter T, or is that just the standard convention?
Yeah, it's just the standard convention.
Right.
Yeah, sometimes you'll see a function using more than one generic, and it'll use T and something else.
Okay.
T just became the standard because T stands for type.
Yeah.
So yeah.
And once that generic is defined the first time, it's going to continue to be that type.
Yeah. So if you did, where's my generics file? So if here you wanted to not use T, you wanted to use X for whatever reason, right? You can just do, oh shoot, that's right. X, and then everywhere you're referring to this generic type, you just now have to refer to it as X.
Okay.
Yeah, it doesn't matter. T is most widely used because T stands for type.
Okay, for the plain example, you had interface plain, but a more generic object would be like a vehicle. So you do like interface plain extends. Like
yes, you can extend interfaces as well.
Okay.
That's right. I did not go over this. That's yeah. Thank you for asking that question. That's great. Where is the car and phone thing? Is that in here? No. Union. No. Untyped goodness. That's where it is. Okay. So instead of doing this, where display name and ID both exist in both of these, I could also do interface. I don't know. Object.
Yeah.
No, object is a reserved word. We can't do that. Let's say DB object, right? It's like something. If something's coming from your database object, it's going to have a display name, which is a string, and it's going to have an ID, which is a string, right? And so now you can say extends DB object, and you don't need these. And then same thing with here, extends DB object, get rid of these two, and you can see TypeScript is still happy, no red squigglies, because they're both going to have an ID and display name.
That's awesome. You already mentioned how this is a free unit testing.
I think I mentioned in passing. It definitely came up a little stronger yesterday.
Yeah.
But yeah, this is definitely like free unit testing. If I come back into here, right, you can see immediately it's very visible. You don't even have to actually run a test. It's very visible. Shoot, I misspelled January. Boom, the end. Again, if I am, trying to call, so like down here, if I'm trying to call sum with this crap, it's like, hey, you can't do that. The X is not a number. You can't pass in a string. That doesn't make sense. Same with diff, divide, and then full name. Hey, this needs to be of type person. So yeah, it is free unit testing in VS Code if you do something wrong. Prior to TypeScript, if you did something like that, you would never know until you ran the code, saw something weird was happening, and then started digging. And only once you started digging would you realize, oh shoot, I'm passing in a number where I shouldn't be.
Maybe one more question.
Mhm.
So like, when you have an object, or like when you return like an object and you just print that object itself or whatever, what does it print, like all of its attributes, or like, because I know with Java it either like when you return an object or when you print an object it like prints out like its attributes based on its toString method, or like or it just returns like the object's like address and memory or whatever.
Right.
Depends.
If you so like here you can see I did it here with birthday,
So,
and it looks like, I swear I had this here somewhere, right? Yeah, like that, right? So it just like spits it out in the curly brackets, and it's like here's the keys, and then there's the values for each key.
is there any way you can like change that printing like so you can say like it's like calling its own like toString method if you think about it, right? If that kind of makes sense.
No, not with JavaScript. JavaScript just knows if you get an object, this is how you should spit it out.
Is it always going to print that way?
Yes.
Okay.
Yeah, if you're printing out an object, it's going to just spit this out.
Can you customize that to print it your own way?
Yeah, I'm sure you could. You could come up with whatever function you wanted that took in an object and then just iterated through the keys and printed them however you wanted, right? So like if you wanted to, let's say you wanted to do, you wanted them on new lines, right?
Sure.
You could do like object, let's do this first, console.log, open curly bracket, right? And then you could do object.keys, birthday. That's going to loop through every single, this is going to loop through every single key, right? And so you do key console.log. Console.log will always print to a new line. Then you can do, let's do this thing, key, and then birthday at key. No, wait. Yeah, why is there an element implicitly has any type? Huh? I don't know why it's yelling. And then, then at the end you can do console.log, close the bracket. I don't know why it's yelling, but as we learned, it'll still run the TypeScript or the JavaScript just fine. So dist/TypeScript.js. That did not work at all. Oh, I didn't compile. Yeah. Note to self: if you don't compile your code, it doesn't change.
Okay.
Yeah.
Cool, thanks.
Yeah, that's it. Awesome. Thanks for coming. Thanks for the questions.
Thank you, Chris.
Thank you.
Thank you, Connor. Uh-oh.